with Peter Zalin, who will give us an overview, of ProScale applications and further options for product environmental footprint. Peter is currently the Director of Sustainability Methods at BASF, and he's also an honorary Professor of Sustainability Management at TU Dresden. Thank you, Peter. Go ahead.
Thank you, Genevieve, for this kind introduction, and welcome from my side. I'd like to introduce you a little bit on part of the history, but also on the setup of ProScale and why we started to develop this one. And we were one of the founding companies that started these activities. With the next slide, I give you a short overview where we are coming from. If you can switch to the net, yes, thank you. So starting with the question, how industry handle classified chemicals? You know, chemical industry has classified chemicals, and there are a lot of tools, applications, but also regulations like REACH, which controls risk from chemicals, but also CLP that has a harmonized EU hazard symbols and health risk communication, but also now in new parts of the Green Deal, eco-design looks for sustainable chemicals, and also toxicity plays an important role. Also in SSBD, safe and sustainable by design. But also, and that's a bridge to life cycle assessment, also in the product environmental footprint, where most likely this year an updated methodological paper will be presented, and human tox and ecotox will be an important part of that. And for sure, for chemicals, toxicity is an important element, and we in our industry we handle the things since decades in a safe environment, and that's the idea that you cannot have unsafe handling of chemicals. So you have to do everything so that a safe handling is possible for workers, but also for consumers. Next slide. There you see a little bit how we addressed that since many years. So we have to have a risk analysis. We have to make a risk assessment. We have to check what the human exposure is on workers, but also on consumers. And then we have a start. We implement the hazard of a material. But hazard is not the only thing. So we need really to focus on risks. So workplace safety plays an important role here with a risk assessment, but also environmental protection, assessing risk from chemicals released to air, water, and so on. Product safety deals with management around that, so that the safe handling can be established, and also it helps also in the decision making. So risk assessment say if and how a chemical can be handled safely. LCA, and in the next slide, I show you then the bridge to life cycle assessment. And you know what life cycle assessment is doing. So I have here a graph where I implemented a PCF, product carbon footprint, from tier N to OEMs, and you always have the emissions of the process, and you have the upstream impacts as well, and you sum them up to a product carbon footprint at the end. You can do that in principle in the same way for human tox and ecotox element. And there ProScale comes into the place where we say, why not using what we have established and used for many, many years and decades in chemical industry? Why not using this approach and transferring and using that in a life cycle assessment approach? And that was the starting point of ProScale, to think about how can we use available information, how can we use what is there, what is officially accepted, and how can we transfer that with ways how we handle these things in the life cycle assessment arena. And at the end, similar to the PCF, we want to have a figure, we want to have a number for that, so that you get a feeling how big is, or what is the altitude of PCF, and what is also the number for ProScale. That has nothing to do with safety at the end, because as I showed you, safety is a different topic, but we use elements out of this assessment to bring it in a life cycle assessment perspective. Next slide, please. That's the reason why we developed ProScale. We wanted to ensure to take into account the chemical risk-based elements in the lifecycle assessment of products, and we want to prevent the use of hazard-only assessment methods, because hazard does not say anything in our world, so we need to have this exposure part as well. And that was a key element of ProScale development, that we wanted to introduce these elements in our methodology. And we haven't seen there was a gap in LCA. It was not covered in that way when we started with ProScale project. Next slide, please. We received also, together with CEFIC, an award for ProScale, and that showed also that we are on the right way, that we can support chemical industry, but also our consumer industries that are using chemicals with these meaningful, interesting, and important information. And so that was a recognition of our work there, and ProScale was awarded by the CEFIC organization, which is a European chemical organization, with the European Responsible Care Award in 2024. So that was a nice recognition, but shows also that we are on the right way in supporting industries with meaningful information in the arena of sustainability assessments. We also developed a database in this, which is available. So it's a growing database. So we also always thought about how can that be applied. It's not only a theoretical approach, it's really a practical approach, which practitioners can really use. And this database gives complete and checked and established data that everyone can use at the end for a life cycle assessment, which is clear that we are not doing a risk assessment. That's a complete different arena. We are really here in the life cycle analysis and assessment arena. With the next slide, please. I give you an overview from industry perspective on ProScale. So the objective was positioning ProScale as an easy to use and meaningful human toxicity assessment method, but also in consideration of the things that the chemical industry has in hand and has available. So that was the starting point of this industrial consortium in 2016, with companies who are still in this project and further developing things. And the idea was bridging lifecycle assessment and risk assessment expertise together. So we had a lot of experts from these companies, toxicologists, and a lot of expertise how to bring to merge that from LCA expertise and from risk assessment expertise. We wanted to address also or develop a methodology where you have easy to achieve data. So use existing data. I mentioned in the beginning REACH. So there are a lot of information there. We have technical information. We have risk and direct exposure information. We have calculation tools of exposure. All these things we implemented to ProScale and make it usable and transfer that to an LCA perspective and user perspective. In general, we want to provide a complementary approach to other options and to other elements in the LCA. So it should be LCA compatible. And that was also one of the goals we achieved during the ProScale development. In the next slide, you see a little bit what the scope of ProScale is, and also of USTOX, which was also established in that time for LCA, and it's still used in ProScale in the environmental footprint and the product environmental footprint of EU, which is, we think, the good way is a complementary approach, because USTOX and ProScale, they have different scopes. You see the scope of USTOX is to cover humans via the environment. The same for ecotoxicity via the environment in the long-term perspective. And we address more address a direct human toxicity based on hazard and exposure of workers, users of toxic substances. And you see it's a classical LCA way to do that using available information. We can do that also in the cradle to gate or cradle to grave approach in a lifecycle assessment. Raw materials are established production, but also professional use and consumer use. Service life is something that is a new element there, will be introduced today as well. And for sure, also covering the end of life. So the typical life cycle system boundary perspective and unit process perspective was implemented to ProScale. In the next slide.
Peter, if I may ask you
yeah.
to be fast, because we need some more time for the other presentations.
I will jump on, so sorry for that. So just the last slide here, just to show how it can be implemented in LCA with all the other environmental impacts. You can have also human toxicity in here, and you can reflect that, and you can address it with ProScale methodology. At the end, you can also summarize it, and you can also aggregate the figures for better interpretation. So human tox and also ecotox can be addressed with ProScale. One click more, and then I'm finished. Finishing. Then you see also that then aggregation is possible. So also the interpretation of the results is clear how to do that, and supports practitioners in application of life cycle assessments. So with that, I would like to thank you for your kind attention. Sorry for being a little bit over time. And so this slides, there are some summary slides in there showing also companies who are involved in there, who are supporting this development and ProScale consortium, and bringing that forward and integrating that in our common practice. So thank you very much, and back to you, Geneviève.
Thank you very much, Peter. Just in passing, of course, the presentation, the slides will be made available after the meeting. So you will have plenty of time to dive through the details of Peter's very detailed presentation of the method as such. We now turn to Erwan Saouter. He will walk us through a brief reminder of the respective strengths and weaknesses of risk assessment and LCAs, and also show us why combining both approaches is really essential for effective environmental protection. So Erwan is an independent scientific advisor specializing in SSBD, LCA, and chemical risk assessment, and he has over 30 years of experience at company, consultancy, and also government level. So, Erwan, the floor is yours.
Yes, thank you very much, Geneviève, and thank you for inviting me for this short talk. So basically, I will try to address what a question that both risk assessment and LCA practitioners have in mind when they think about the tools that others are using, and try to explain why both are needed. So next slide. I will start with the perception that many risk assessment experts may have toward life cycle assessment with this type of questions. Why bother with toxicity impact categories in LCA when we already have risk assessment? And that's the questions that I have heard many times from people working on SSBD, on safe and sustainable by design chemicals, where they question the needs to have an impact category score on toxicity. Of course, they see the need of having LCA because you have 15 other impact categories, but they question the needs of this specific human toxicity and ecotoxicity. Because indeed, REACH or risk assessment already ensure that substances are safe when they are used in products. They use high quality toxicological data, GLP, standardized, you have OECD protocols. To understand and analyze ecotox or human tox value, you need a huge amount of expertise. So that's not something that is quite easy. So it's a lot of work. There's a regulatory framework where you have to report this data and report the outcome. And it's already proven safe. So why do we need LCA? Next slide. And if we do the same with the LCA perspective, but I would say I hear less this type of question, but why bother with risk assessment when LCA already cover human and aquatic toxicity impact? And the argument that could be put on the table is that LCA evaluates thousands of substances at the same time, all the life cycle is taken into account from cradle to grave. LCA enables direct comparisons of alternatives. So if LCA cover toxicity, why do we need risk assessment? So next slide. So indeed, there are two communities, and still today, after 30 or 20 years of LCA and risk assessment discussions, I've been to many meetings and conferences in my life, and there is still this type of question of skepticism between the two community. And the LCA practitioner, they see risk assessment as much too conservative because we use assessment factors. Many think that we only use acute toxicity, where actually in risk assessment you have a tier approach. There's also a single substance focus, so basically one chemical at a time, and then you don't address all the chemicals that may be emitted in the life cycle. It's not really suitable to compare products. There is no really methodology for that. The life cycle is also limited. And then you ignore the toxicity below threshold aspect. And indeed, this is a big aspect in risk assessment. It's a dose that makes the poisons. So basically below a certain concentrations, you don't care about the fact that there is a chemical in the environment because there is no impact. While in the LCA, every teeny amount of chemical will contribute to the score. So picograms of anything will contribute to the total score. And then for risk assessment, LCA is to simplify. There's not really regulatory use of the LCA. There's a lack of a site-specific relevance. I mean, risk assessment is really site-specific. There's no direct link to toxicology, so you cannot say from an LCA if really the product will have an impact on people or on the ecosystem. And so on. So basically, any emissions, indeed, what I said before, has an impact in LCA. But actually, the paradox is that today, if we look at the main LCA methodology, so USTOX, Recipe, and others, and also ProScale, they use the same approach, the same foundations, which is basically the simple box fate modeling, physical chemical properties, and also toxicological data. Maybe the issue is how these tools and data are used in both approach. So next slide. Yeah. So indeed, you have seen that maybe before. The big difference between the two approaches is that in the LCA, you aggregate all the emissions coming from all the life cycle stage, from extraction of raw materials, productions, and use phase. And then you get a score, one single score for human toxicity, one single score for aquatic toxicity, coming from all the emissions pulled all together. While in risk assessment, in principle, you should do a risk assessment for every single chemicals going to a very specific environment in each of these life cycle stage. So it's really a completely different methodology, but of course behind that, you may use the same data. So next slide. So basically, the question that is asked is completely different. A risk assessment is really looking at safety. Is it safe here? Is it below the threshold? It's really yes and no answer. It's site and scenario specific. And the output is really PEC-PEC, so predicted environmental concentrations compared to predicted no effect concentrations. And basically, if it's above 1 or below 1, it's safe, and then you can stop. And if this is not the case, then you can go and generate more data, like chronic data, to try to demonstrate safety. Next slide. The life cycle is more about the burden. So what's the overall burden of this product life cycle on the environment? And then you try to identify the best alternative that puts less chemicals, less emissions, less energy consumptions from a life cycle perspective. And then you use that to compare NAB. So it's really an aggregated score that you get at the end. Next slide. And indeed, the tools also, I mean, big differences is about the tonnage versus functional unit. In risk assessment, you are going to use the total tonnage that is going to go in a very specific environment to calculate environmental concentrations. while in life cycle assessment, you work based on a functional unit. Basically, the emissions linked to the washing of 1,000 load of laundry, and then you are going to compare two products that could deliver the same functions and see which one will have less burden than the other one. So that's also a big differences that needs to be understood. Next slide. There's also this sample box. In risk assessment, indeed, we use sample box to calculate PEC regional, PEC continental, and PEC local. And these PEC are really used to try to estimate the risk of the chemical in this specific environment. While, next slide, for the use stocks, you also use simple box. And in this case, you don't have the same compartment. You have global scale and continent scale, and then urban air and indoor air. And then you use that to calculate more residence time, so basically a fate factor. You are interested to understand how long a chemical is going to stay in specific environmental compartments. So out of the LCA, you don't get concentrations, you get residence time. Next slide. So uses or KESA or whatever in risk assessment, they really have a mandate of making clear that the chemical is safe. I will not repeat myself, so click again. And then what the tool doesn't address indeed is multiple exposure. It's a different exposure time through the day. Mixture exposure is not really taken into account today. There's today the development of additional safety factor maybe to account for this mixture effect. And then you don't do comparative ranking. Next slide. The LCA, indeed, you get a fate factor, an exposure factor, an effect factor if you use stocks or a recipe. And then indeed, LCA, as I said before, doesn't predict actual impact on real populations, it doesn't provide the safety threshold, and do not replace risk assessment. Next slide. So one thing that we need to acknowledge also is that risk assessment and LCA may not identify the same chemicals in terms of the top contributor to the LCA or the top contributor in risk assessment. If we look at the LCA, most of the time when you look at the contributor that contribute to the overall toxicity impact, you end up most of the time with metals. While with risk assessment, you end up with other type of chemicals, more organic chemicals. It doesn't mean that one is wrong and the other is right. Both get an answer which is different because the methodology behind is different. So next slide. So indeed, I conclude with this slide that you could expect that indeed we need both. We need both in SSBD because risk assessment will ensure that the chemical that you are going to put in your product is safe for humans, safe for the environment. And then LCA will provide additional information about the overall burden of this product on the environment. And next slide, and that will be my conclusion. So I hope I'm on time. So risk assessment answers the question about safety. LCA answers the question about burden. And of course, we can always discuss about different methodology. To do that, there are different tools, but it's really important to understand the questions that each tool try to answer. Same scientific foundations, but maybe a different way of using the data. LCA and risk assessment, we are comparing versus safety thresholds. And then one important watch out is that the top contributor in LCA and risk assessment doesn't match. So we need to understand that and make the right interpretations when we do an LCA and when we do a risk assessment. And then the last one is that both approaches are necessary and neither one is sufficient alone. So that's it. Thank you very much.